In section 2.5, we're going to talk about a method called completing the square. This actually will help you see the vertex form that you were first introduced to in section 2-1. So we're going to ask how you can use a quadratic equation and complete the square to help solve it. One of the first methods that we're going to talk about for solving a quadratic could be taking the square root. So we actually call this the square root method. And you've seen one like this before in section 2.4. So for example, x squared equals 25. If you take the square root, the square and the square root are inverse operations. They'll cancel, so you're left with x. And don't forget that the square root of 25 is not just 5, but it's a positive or negative 5. And now we have the answers to what will make this equation true. Just a side note that if you ever wanted to, you could take your x squared and subtract 25 from both sides. Move this 25 to the left, which we did in 2-3. Then you could set up your factors and do x plus 5 and x minus 5 to find your zeros. And of course, we know negative 5 would make this factor 0, and positive 5 would make this factor 0. So we would say these are our zeros of the function, or where it crosses the x-axis. But note, we actually found that this was the factoring method, which we were doing in 2-3. The square root method, we just were able to take the square root of both sides, maybe a little quicker. It gives you your zeros right there, and they do match. So another example here, x plus 4 squared equals 25. Just because this isn't x alone, we can still use the square root operation to take the square root of it, and square root and squared would cancel. We'd have x plus 4 equals the square root of 25, which, just like on the last problem, we would know is plus or minus 5. Now, this one, we do actually have this plus 4 to deal with, so we can't just be done and say the answer is 5 like we did on the first example. This is where we need to branch out. So we could say x plus 4 equals a positive 5 and x plus 4 equals a negative 5. We need to give both of these options. So if I subtract 4 from this side, I get x equals 1. And if I subtract 4 from here, I get x equals negative 9. Now, these still, like the last one, find our x-intercepts, or our zeros. But one thing that's kind of interesting to note, if you remember from 2-2 or 2-3, where you were supposed to take the vertex form and multiply it out into standard form, you might take something like this, x plus 4 squared equals 25, and multiply out your x plus 4 squared. And so in quick form here, what I did was I took this peak box right there and I actually rewrote it up here. I squared out the x plus 4 times x plus 4, made x squared plus 8x plus 16. I set it equal to 25. And just as you've done before, I got everything to the left side, like in section 2.3, and I got minus 9 as my c value. A little side note again, remember this c value when you have it equal to 0 is your y-intercept, just a hidden key feature there. By factoring it, I found positive 9 and negative 1 to be in my factors. Therefore, my x-intercepts, or my zeros, are the same as what I found down here. Again, move everything to the left and factor is one way to solve it, or the square root method will also work. It's important to remember that you'll be tested on all of these methods, so make sure you've seen all of them and you could use the appropriate one when asked. Now here we have a quadratic on the left equal to 100, and it makes me feel like, gosh, this right side is a perfect square. I wish this left side was, just like x plus 4 squared was. But if we were to factor this, we would see that it's x plus 5 times x plus 5. Because 5 times 5 makes 25, and it adds to 10. So we could rewrite it as x plus 5 quantities squared equals 100. Get our square root, our solving by square root on again there, and go x plus 5 equals plus or minus 10. Now this is where we branch off, and our one solution equals the positive 10, and our other solution equals the negative 10. If I subtract 5 from this one, I get negative 15. If I subtract 5 from this one, I get positive 5. Those are our x-intercepts, or our zeros of the function. Right here, if I want to look at the key features along the way, if I would have taken this guy right here, remember vertex form we learned about? I think again it was in 2.1. If we had y equals, we'd have x plus 5 quantity squared. If I would bring that 100 to the other side by subtraction, I'd have minus 100. That would tell me my vertex Remember that rule, the opposite of the x values would be -5, comma, -100. That would give me my vertex, that key point, quite easily right there. I found my x-intercepts by either using the square root method, or I could factor it as well, which I won't show that method in here. The only bonus, if we wanted to subtract this 100 first, before we did factoring, we'd have x squared. Let me change this color here. We would have x squared, x squared plus 10x minus 75 equals 0. If we decided to subtract that 100 over, there would be your y-intercept. So just keep in mind all those key parts of the graph that we can use to sketch it without using Desmos, which you will be required to use, have Desmos on your test. So be able to move those terms around and find key features without using a calculator. The first few examples you saw weren't in your packet, so just kind of bringing back that packet work here. We have Hannah and Enrique. Hannah has decided to subtract that 16 over, like I mentioned, and do some factoring to find her zeros. One nice thing is along the way, she actually finds her y-intercept right there. Enrique, he chooses to what we're going to call completing the square here, but he has found that this is a perfect square, x minus 3 squared, and then used that square root method on both sides and found the same zeros. You could do the packet. Example 1, I'll do one of them here with you. We see this right side, and you may or may not recognize that that's x plus 7 times x plus 7, which is the same thing as x plus 7 squared. So we can use that square root method to quickly solve for the zeros. We'd have a plus or minus 5 equals x plus 7. And here's where we branch out. X plus 7 equals a positive 5. So we want to subtract 7 from both sides here. And that would give us a -2 for one of our zeros. And then, of course, x plus 7 equals -5. X would be -12. Those would be your zeros. Again, you can see those key features of the zeros after doing the square root method. You could have subtracted your 25 over and tried to factor. Lots of different methods there. The triads are the same way, where you'll notice you can use that square root method very easily. Now we're going to look at an example here where I can tell 80 is not a perfect square. And so I want to do some things to try to make this into that perfect square, which is actually what we're going to call the process of completing the square, so I can use that square root method. Now, before I begin that awkward looking one, I want to look back at this perfect square business. Do you see how we had x plus 5 and x plus 5? Look at our middle term. We had 10 as the middle, 25 as the c value. Look at the example from the packet. We had on Enrique's method, we had x minus 3, so minus 3, and then a 9. Notice how that 6 here and the 3 and the 9 are all related to each other. Let's try this last example. We had 7 and 7. 7 times 7 was 49, but 7 plus 7 was 14. They actually had to add to that middle term. So if we look at this example, we're going to use our box to help us. I'm going to put my x's on the side of my box, and I know I want that to be x squared. I want these two values to be the same number, remember, because then I can say it's x plus that number squared. The way I'm going to guess what that number is, whatever this term, the b value is in the middle, I'm going to take half of that. So half of that would be 8. If I put 8 here, and I write x plus 8 times x plus 8, these middle terms, so 8x and 8x, will add to 16x. I need that to happen, because then eventually I can write x plus 8 squared, and that's my goal. The problem is that 44. It is not a perfect number. So if I finish filling in my box, I have 8x here and 8x here, just like I did with those inside and outside rainbows, if you will, or distribution there. That makes my 16x. I want this final box right here to be what 8 times 8 is. I'd be 64. I only have 44. Well, if I add 20 to this side, there's nothing wrong with it as long as I add 20 to the other side. So what I would have left, I know that 8 times 8 is 64, which 44 plus 24 is now 64. So I have accommodated these 8 times 8 to make 64 a perfect square by adding 20. And I've kept the equation balanced by doing that to the right side. But now on this right side, 80 plus 20 is 100. Now this makes us feel a lot better. X plus 8 squared equals 100. Hey, we're set up just like those other problems were. Again, a little stop point here. If you were to take this and put it into vertex form, you would have your x plus 8 quantity squared and subtract your 100 over. You'd have minus 100. Your vertex would be at negative 8, negative 100. Just a side note there to make sure you can see those key features as you're solving. Let's use our square root method on both sides, and we square root here. We'd have x plus 8 equals plus or minus 10. And then this is where we write both of the options. X plus 8 equals 10 and x plus 8 equals negative 10. X will be negative 18 and x will be 2. Those would be our zeros. We can do it even again. Now this has worked out nicely because these last numbers have always been a perfect square. They don't have to be. We have been working with examples with reducing radicals. Say if you wanted to reduce square root of 25, we've been practicing that. That one doesn't scare us because we know it's a perfect square. But square root of 27, that's also doable. It is an irrational number, but we can reduce that radical as well, which you've been practicing. So let's look at this example. Here I want to make my perfect box square. So I know x times x needs to make x squared. I want to get this left side to be a perfect square. And I know I need to split this b term up nice and evenly. So what this number plus this number will add to 6. So 3 and 3 would add to 6. I'll have 3x and 3x. That will make a total of 6x. Well, that means I need my c value to be a positive 9. And I only have 3 right here. Well, if I plus or add 6 to both sides, I will get the 9 I want. So this would be x squared plus 6x plus 9 equals 6. I have now modified my equation, but as long as I do to the left side what I do to the right, nothing wrong there. Well, x squared plus 6x plus 9 is x plus 3 times x plus 3. And now it's equal to 6. I can rewrite that as x plus 3 quantity squared equals 6. Always going to show you that side note here. You have basically made vertex form. You'll be saying that would be x plus 3 quantity squared, and you'd subtract that 6 over to the other side. Your vertex would be at negative 3, negative 6. Now, to keep solving this and to actually use my vertex form or my completing the square. So again, guys, what you just did here, you have completed the square. You made a perfect square here. You square root both sides, you'll get x plus 3 because the square root and the squareds cancel, equals, don't forget your plus and minus, but now it just doesn't come out pretty. That's okay. You're going to write x plus 3 equals square root of 6 and subtract 3 from both sides. So you'd have x equals negative 3 plus root 6, or x plus 3 equals minus root 6. Subtract 3 from both sides, you'd get x equals negative 3 minus root 6. Don't try to combine the negative 3 and the root 6. That's as far as you can go. And root 6 doesn't simplify, so we don't need to go any further. So for time's sake, I've set up another one here for you. I knew 8x needed to be split evenly, so I did x plus 4 and x plus 4. There's my x squared and my 4x and my 4x. I need this top bubble to multiply to 16. But I have negative 20. We'd have to go negative 20 and add 20 just to get to 0, and then add 16 more. So we'd actually need to add 36 to both sides. By doing that, this makes the 16 I was hoping for to complete the square. But I have 36 over here now instead of 0. So for time constraints, I have shown you that it can make the vertex form, and there's your vertex. If I square root these, I'd have x plus 4 equals plus or minus 6. And by setting them equal to 6 and negative 6, I found my solution.